Welcome to STEMI and Locations lecture, where we will show various STEMIs and talk about their locations, and of course get a little nerdy. Now we'll talk a bit about ischemia. This can occur due to a stenosis or a plaque that is obstructing blood flow, which prevents nutrients and oxygen to getting to the heart. When ischemia hits, there's a decrease in the function of the sodium-potassium pumps, which leads to delayed phase 3 repolarization. There's several theories why, but we'll just talk about one of the more popular ones. So this is the current of injury theory. As mentioned before, this is the dysfunction of sodium-potassium pumps, which are powered by ATP. There's an increased amount of extracellular potassium, which causes the cells to be in a slightly depolarized state. The cells are mad because they've been injured, and it is hard to regulate their membrane potential because they aren't able to really make ATP due to the ischemia. Now, in an injured myocyte, remember, it is hard for a cell to control the membrane and what flows out. So in this instance, there will be a lot of extracellular potassium. Because there's more potassium outside of the cell than in the cell, the potassium in the cell doesn't want to flow out, which makes the cell more positive and slightly polarized. And because of this, there's an early depolarization and repolarization. So ST depression occurs because of the subendocardial infarction. This is the first stage. The final stage is full thickness, called transmural infarction. So the red circles are our entire myocardium and our ventricles. The gray circle is the ischemic area. The yellow circles are the myocytes, and the electrode is, well, obviously the electrode. Because of the extra potassium around the myocyte, it'll start to depolarize a little bit early. Because it depolarizes before the action potential hits the ventricles, it will stimulate the myocytes around it early, which causes them to depolarize as well, and this will be leading towards the electrode. This process will raise up our isoelectric point, so no longer is at 0 millivolts. The ventricles depolarize, and when it repolarizes, it will return to 0 millivolts where the isoelectric line was supposed to be at, causing ST depression. So now we talk about our transmural infarction, or full thickness. Just like before, we have a bunch of extracellular potassium. And a full thickness infarction, because it is full thickness, the impulse can't head towards the electrode, and the impulse has to head to the sides and away from the electrode. So because depolarization is happening away from the electrode, our isoelectric line will start lower than 0 millivolts. The impulse from the SA node makes it to the ventricles and causes normal depolarization and repolarization in the areas that haven't been affected by early depolarization and repolarization of the infarcted areas, which makes the QRS and ST and T wave hang onto the 0 millivolt area and then return to the isoelectric point, causing ST elevation. If this is confusing, don't worry about it too much. I just wanted to explain why you get ST depression and elevation. So if the injury vector is heading towards the inferior part of the heart, it'll cause ST elevation in 2-3 AVF. Since it's heading away from the reciprocal leads of 1 and AVL, they'll have ST depression. So we can see our various leads here. 1, AVL, V5, V6 show a lateral STEMI. The lateral leads plus V3 and V4 show an anterior lateral STEMI. Elevation V3 and V4 show an anterior STEMI. Elevation V1 through V4 shows an anteroseptal STEMI. And elevation in 2-3 AVF is going to show an inferior STEMI. This is a high lateral STEMI. You can see lead 1 is slightly elevated and AVL is more elevated, and there's also depression in our inferior leads. Our inferior leads once again is 2-3 AVF. We can also see some ST sagging in V2 through V5. And here's an example of your anterolateral MI. We're going to have elevation in all of our V leads, 1 and AVL. We're going to have depression in 2-3 AVF and in AVR. And remember, septal is V1 and V2. Here's your anterior MI. We're going to have elevation in V1 through V4, with depression is going to be noted in V7 through V9. And this is going to be your LAD occlusion. And here we talk about our inferior and posterior MI. We're going to have elevation in 2-3 AVF, depression in 1 AVL V1 through V5. We also have a posterior wall infarct as well. If you do your posterior leads, you might see some elevation in V7 through V9. And this is going to be an RCA occlusion. And that's going to wrap up this lecture. I hope you guys enjoyed, and I'll see you guys at the next one. Make sure you subscribe, like, and check out our other EKG related videos.